Hey, my name is Jay, and I'm going to take you through a beginner tutorial of how to create some resources and how to make a deck of cards in Godot 4. Now, one of the things I see a lot of people new to coding do, especially when creating decks of cards, is they create basically a string of everything handwritten out. And while this isn't wrong, it's just not the best way to go about doing this. And there's a couple reasons why this isn't great. One, it's a lot of manual labor. Two, when you're dealing with strings, you can oftentimes run into issues of typos. And typos in coding are bad. We don't want to run into that problem. So, what I'm going to show you is how to create a base scene for your cards. And then you're going to have a resource that holds the information from those cards, like their suit and what number they are. And then we're going to populate the scene based on the information in the resource. And this is useful for all sorts of things in programming in general. And as you start to do more complicated projects, you might find it much easier to program this way. For example, let's say you wanted to make some weapons in your game for an RPG. You could have a weapon class and your weapon UI, and then the weapon UI loads in all of the information from the weapon, what texture, animation it uses, how much damage it does, and its general behavior. So, first thing we're going to do is we're going to create a custom resource. So if you haven't made a custom resource before, you right click on a folder, you create new, and you create a script. And the only thing that makes this script special for being a custom resource is we make it inherit from the resource class. So when you create one of these, you'll see our new script here extends from resource. And so we can go ahead and close that because I already created a playing card resource. You can see it down here in our system deck or in our file system, the playing card resource. So I gave it a class name of playing card. This is useful because when we say need to reference it later in other scripts, we can hold down Control and click on the class and it will bring us to this script to kind of show us what's going on. You can see an example of that of this resource class. If we wanted to know more about that, the Godot 4 is great because we can control click here. It'll bring us right to the documentation for what a resource is. So after that, we'll give it a simple description. It's good to put notes and descriptions and things in your um, games in your code just to make it easy to understand. You can even do that as well down here with our variables later, but I just didn't. I believe we put it right before. Let me check. So wrote it right there. So now if we look at one of the resources and we go over, you can see it's written there. So if you want to describe one of your variables when we get to them, this is how you do it. I'll put a space there so we can see it. But so I'm trying to follow the style guide as much as possible, given it's for new people. So I'll go through, there will be constants and enums at the top, signals are above those, and you can get to the style guide by just typing into Google or whatever search engine you use and pull up the Godot documentation and you can find the style guide pretty easily. It'll tell you how to name variables, using the format that's expected, including the side and how to name your classes. It's really useful. So you can see variables here in kind of this lowercase with the dashes. I believe it's snake case, whereas enum names you constants we use all uppercase. Enum names use uppercase with the just on the first letters, and then the capitals for the references. So first thing, we'll make an enum for the faces of the cards. So there's only the Jack, King, Queen, and Joker's face cards. I put in null because if we want to reference that, it's good to have at the beginning of your enum, because if you add it later to the end, you have to, if you have, say, a bunch of resources, you'll have to redo all those manually, and it's a real pain. So it's good if you're going to have null or some kind of catch-all category, have it at the beginning. We do the same thing with suits. We've got null and then our suits. And now we get into our variables. So an export variable is basically making it so the variable will be over here on the side of the inspector. You can see we have our variable here is numbered card, and the colon here means that when it shows up in the inspector, it's expecting it to be this class that we named here. So we're expecting it to be a bool. You can see over here that it's a boolean. And like I said, if you want to, say, give the variable description, so when you hover over it, that'll show the description, you can do that as well. So we have a boolean for a numbered card, a boolean if it's a face card. We gave this export a specific range because cards only are 1 through 10 for numbered cards. So then we also have our number here, again over here, and then an export for the face. The face is expecting it to be one of these enumerations from this face up here. So you can see over here, if we click on this, we have our list of enumerations, and the same thing for suits. Now, an enumeration on the computer side, while this is human readable for us as constants, the computer reads this as numbers. So if we, say, reference this later with code, or if you wanted to, say, try to print it because you weren't sure what was happening with your enumeration, you're only going to see the index numbers here. So it'll be 0, 1, 2, 3, and 4. So this is all we need for our playing card resource, and very simple. So what we can do is, now that we've made our playing card, we can also make a deck resource. So same way we did down here, right click, create a new script, and then I made that script a resource, and we can see this deck. Now I made the deck resource because it's more of an example. You could just list all of those cards and put them into an array, but sometimes you might want to make, say, pools of objects, and having a designated pool for the object is a good way to do it, especially with a deck of cards. It just makes sense. So this class is very simple. We can see it's just an array of our playing cards. And like I said before, if you hold down Control, you click on that, it'll bring us to this playing card script. So in the file system, now we can create those resources. So I can create new resource, and if I create a deck, I can just name it new deck. And if I double click on this, you can see it over here on the side. So our deck is this one variable. It's an array. But the fun part about this is, so now we're into the point of, what do we do with these card resources? So we could either manually create all of the cards, which is kind of the same thing I was saying not to do before. But at least this way, if you wanted to manually create it, you can just click here, new element, click here, new playing card, and then you can just check these boxes. So numbered card, 1, Jack, hearts, right? Or it's no, 1 of hearts. If we want to make the 2 of hearts, easy. Playing card, numbered card, 2, and hearts. So you could do that for all of the cards, and you could make your whole deck of 52 cards. Now, I would recommend doing it a different way. I would recommend just scripting it. So I wrote a simple script, a function really quick, and I don't have it implemented to run right now, but I did test it and it does work. So if you, say, wanted at the start of your game to just generate the deck, and this way you don't have to type it all out, it's just 42 lines of code. So this actually took less time to write than it would have if I just manually made all the cards myself. So first thing we did here, um, created a function, gave it a good name, gave it an option to if we wanted to add jokers or not. So first thing we did was I created a new um, deck resource. You know, like I said before, it's our deck of cards. Then we go through and for each suit, I in playing card suit, if I press control again, you can click here. So I in suit will iterate through each of these. And then we will try to match that I. So we'll skip over null because null suit doesn't do anything. And then this with the little dash and the colon will then match everything else. So for every other suit, we will take the numbers 1 through 10, and in a for loop, we will create a new card. We will apply all of the information we need for the card, and we get the number from here and the suit from up here. And then we'll append that to our deck of cards. So now we have a deck of cards with, um, 1 through 10 of each suit by the time we get to here in the script. So now we have to do the faces. So we'll add the face. We'll skip over null. Same thing of playing card faces. We'll skip null and we'll skip joker. So skip null, skip joker. Then we go here to everything else and we will set it to numbered false, face true, and we will set the face to F in faces and the suit to matching the suit up here. And now we already have a whole deck of cards. So I have every card in the deck. And then if we want to add jokers, we can do that down here. Now another thing I wrote out in my Reddit post was we can do filters. And this is going to be a little bit off because I'm copy and pasting it. But because we created a deck, we can create filters. And this is going to be, let's see, let's just fix this really quick. In Godot, you have to use tabs. Don't mix tabs and spaces. If you do, it can get mad. So this is a, let's see, deck of cards, not weird. So we'll just do deck. We'll set this really quick to a variable up here. Okay. So you can set filters here. I'm not going to bother fixing this for now. I think it doesn't like this here, but it's still highlighting it for some reason. Oh, this is why. Deck, append, card. Um, but so basically, if you set a variable for your deck of cards, right? You make a new deck, um, and you have it equal your previous deck of cards. You can now use what these are called our anonymous functions to filter, and it's part of the array methods. So if we look at the methods of an array, it has a filter method right here. So you can set up filters. Here it is, like I was saying, the anonymous function, and then it'll give you just the information you want back. So this, when I fix this, will basically give you, say, all of a single suit of cards. So that's one of the reasons why having a deck would be useful. So now we've gone through a simple way to generate the cards. We've done a simple playing card resource. Now I'll show you how to make that visually represented. So here you can kind of see what we're expecting the card to look like. And um, this is pretty simple. And I did some things in a way where it's not necessarily the best way to do it, but it's really easy to do for someone, say, new to the program. So our root node is going to be a color rect. It's a type of control node. I just set it to a white rectangle that's 250 by 350 pixels, the standard size generally of a plane, or standard ratio size of a playing card. And then what I did was, you you want to try to use control nodes to organize things when possible. Another thing you can use is canvas layers. You can get into some trouble with those, with trying to hide and show things. Um, but generally, control nodes are very useful, and the basic thing you should be using to organize how things are, say, anchored around an image or scene. So we have our numbers here in our control node. I can hide and show those. We have our suits, and we've got our face. So the main reason to use control nodes is for this anchoring function. So now that I have this control node under our root node, the root node being this color rect, I set this control node to be full rect. Now, when this is full rect, it means it's the full size of our background. You can see that's represented here. And then when I go to my upper number now, I can set this anchor to top left. And then I set its size. You can kind of pick whatever size you want it. For this demonstration, it's 70 by 70 pixels. Um, and so, same thing for the lower number. The lower number, I can also use an anchor. I set it to bottom right. And so the benefit to this is, let's say you need to change the size of the card. If I change the size of my card, the anchors will stay in the same place. Now you might have some scaling or other issues that you can fix, if you did things differently than how I did, especially with these pivot offsets. But like the pivot offset right now for the bottom corner is half of the size, because if I say fix this, you can see it's over here. But so I need to set that. You could set that with code if you wanted, to make it so it'll always work. But what I just did was, say, rather than doing the math, we can take half our size, 70. You just type in 70 by 2 here, hit enter, and it'll do it on its own. So the inspector will do math on its own. And so I did the same thing with the suit labels for the upper and lower suits. I just kind of moved them into a lower position and mathed it out so it's the same. You could put the upper and lower suits into um, VBox containers. A VBox container is a type of control node where, as you place child nodes under it, it'll put them into kind of a vertical orientation. But for simplicity, I just didn't do that in this scene. So I made Joker labels separately and just kind of placed those. And the face card, same kind of thing. I created the face area under the face full rect. So if things move around, it'll kind of stay consistently. And then I just kind of set some suit images in a good spot as well. And then all of this is actually going to set these via code. And the reason we do that is so we can take the card resources that we have, and we can just load them in. And it will change what happens in the script. So if you can see right here, we've got it as a one of the ace of clubs with this Joker face card background. But if we run this, we can see that it becomes the ace of spades. So I'll show you how we did that just really quick. I'll do a quick change on our script and run it again. Just commented a line out. Now we have a Joker. So that's using our test card. Let's say we want to change it to the Queen of Diamonds. We'll run it again. Queen of Diamonds. So I'll run through this line by line and kind of show you what I did. So added a script to this base node. I gave it a class name of CardUI, extends color rect like we said before, and a short description. So first thing I do is I have constants for all of the images, and this preloads in all of the images. We can see it in our assets folder down here. Now, I didn't I just went and drew up some images really quick using Krita. It's a free art program. And when I drew them up, I made sure they were white images on a clear background. Now, this is important because I'm using the modulate property of the nodes to change the color. You can't modulate on a black object, so having a white picture is really easy and makes it simple. So you have to preload these images to be able to load them into the sprite nodes. So instead of typing all this out, I just selected these, and if you drag and hold control after you drag over here, you can just put them in. And that way you don't have to worry about, say, mistyping something. So I also included, for testing purposes, a test card and the ace of spades, which are two resources that I made down here on the side, you can see. So if I double click on ace of spades, you can see it's a numbered card. It's number one and it's spades. Our test card, like I just showed, face card, queen, diamonds. So now we get into our exports. So I set an export node, and this is so you can say set the card via code. So this export variable, we can see it up here. It allows you to say drag and drop a resource in here. But what you're going to see is so you would expect this to be the ace of spades. Let me comment out our debugging down here. But when we try to run this, what's going to happen is we get an error. And the reason we get an error, and we can continue past it and see that nothing happened, right? It didn't change anything. The reason we're getting an error is because we're using a setter function. And you can see that here. So a setter function means if this card variable changes, it will run this function. And we can see this function down here. It'll run the function using this variable, which is our new variable we just put into the card variable. So this is why we're getting an error, because it is trying to run this setter function before the onReady variables load. And typically you can get around this by, say, putting if not ready, await ready, something like this. And that's a good way to get around this, because it's if the scene is not ready, it will await the ready signal before it starts. However, with a setter function, that doesn't always work. In fact, most of the time it doesn't work. So you would need to instantiate this scene, and then after the scene is instantiated, you then load in your card. So you would do something like var new card UI, equals CardUI dot instance and instantiate um, let's see, instance, but I think I have to we have to do this in a fun way. So I need to have the scene also as a constant, right? So same thing, control click the scene up to here, and now we should be able to instantiate it. CardUI instantiate. So you would have to do this first, and then you would do, say, uh, new CardUI dot card, and then set that to whatever card you want. So when you're actually instantiating your card scene, you can just set this via code, and that's what this export variable here does. But for our testing purposes, I need to, say, assign it manually. And that's what I'm doing here with this debug function. Whereas I'm just assigning it manually in the ready function based on our debug constant we put up here. So like I said, we've got our test card, we've got the ace of spades, and then here's where we choose which one we want it to be. I've been using this test card variable or test card um, resource because it's just easy to change that way. So after we get to the export, you can see our on ready variables for our uh, nodes. And so this is how you reference a node via code. And what I did too was you can see this little modulus symbol here. That means what I did was I clicked on all of these that I wanted to interact with. And generally, it's good to give them a unique name. For nodes that you actually interact with in code, giving them a unique name, when you drag it over here, we'll have this modulus. But you can see it's not the entire, say, node hierarchy. So if you move these around, and let's say you're moving nodes around a lot, having a unique name is good because it'll keep the reference here. Instead of, say, if I drag this one over, you can see it has the full node path. And you can tell, you can again tell via the modulus or the dollar sign. So if you see a dollar sign in a full node path, if you move this around, it will break this variable in your script, whereas the modulus will not. So after our on ready variables, we get into just setting our card here in the ready variable, like I said, for debugging purposes. But the main thing we're going to look at is this setter function right here. So like I said, when we set our card, so right here we're setting our card to equal our test card resource. This is our test card resource. When I set that, it's going to set that test card resource and all of this data as this new card variable in this set card function. And then we're going to go through and we're going to set the information for the card based on what we see there. And so I've got a couple things we wanted to look at. First thing we want to know if it's a face card. So if it's a face card, I'll hide that middle top and bottom image. So that's this club right here and this club right here. And then we're going to match the face on the new card. So new card dot face, new card dot face we can see is right here. Again, control click and it'll bring you to the script. So this is one of our face enums. So really easy to see. So here we have a match function referencing our different face enums. We could also set it to null. So I could say add, if it's not one of these, we just return because it would break, right? So if it's not one, return. You could add a debug message here or something. Yeah, there's lots of times people use print statements. You can also write your own error messages, so it'll show up in the error tabs. But we'll just add that for null. But in the meantime, we've got our jack. The jack has its own image, and then it doesn't use numbers for text, so we set it for the special numbers. And same thing for the queen, king. And then the joker is a little special because it has its own words down the side of the card. So we instead show those labels and hide the numbers and the suit images. So after we check for the face cards, so if face card equals true, if it's not this, we get to our else function. So for everything that's not a face card, it will set the upper number and lower number. That's these numbers. And then it will hide the image in the face image in the middle. So we can see right here, like I said, it's the jack, right? So if we run this, we have our test card set to queen, the five or queen of diamonds. You can see it's set to 5 here, but it doesn't actually show up because it hides that, like it said. So the next thing we do in our script is we fill in the suit information. So we did the same kind of thing of a match statement. And a match statement's the same as using, say, like a bunch of if statements. But I just find it easier to read, especially if you're referencing enums, because you can just kind of you can see exactly what this is supposed to do. So without even knowing what's in my set card function or set card suit function, it's pretty easy for you to tell what's happening here in the code. So we match the new card suit. Based on the suit, we take that suit name, or we take that suit, and then we reference the image for that suit. And the reason we reference the image for that suit is because rather than typing this out, I could have done this separately for each of these in the match statements, but it's generally easier to not replicate code because if it works for one, it's going to work for all of them. So I made this quick function based on the suit and the suit image for the inputs for the functions or the parameters of the function, and then we just set it. So I set the textures for the upper and lower suit, and I set the textures for the middle suits. And then if it is hearts or diamonds, I set the color to red. Otherwise, I set the color to black. So this set new color function, very simple. It just sets the modulate property of these different images, the sprites. So for the sprites, you have the modulate property. And for numbers, the labels, we have to set this font color property. Now, for some reason, I can't just access it when I type in .font color. You have to use a function for the theme color override, and then this is how you do that. So we use our new color, and we set that here. And Godot has an easy way to reference colors. You just type in color, and you can see that gets us to a color. And if you put a dot, you can list through a bunch of colors, and it's a great way to debug things and or work with placeholders. So I use a lot of color recs as placeholders in when I'm programming, and I just have a bunch of colored rectangles for different characters or things that I might need. But so here we go. That's how we set our functions or set the cards. And we'll look at our test card. So again, our test card, it should be the queen of diamonds. We run this, and it is the queen of diamonds. If we want to, say, change it to the king of spades, we just save this resource with the new information, run it again, and now we've got the king of spades. And so that's an easy way to make a deck of cards and represent it in Godot. So hopefully that's helpful for you, and it's helpful for anyone who might need it. Hope you learned something.